Hello friends, welcome back to my channel. In my last video, we had spoken about a very fundamental class of Java, that is the string class. We had also seen what is the syntax of creating the various objects of a string class. We had seen some really important methods of the string class, and we had spoken about a very important topic about strings, and that is string immutability. In case if you have missed seeing that video, you can check out the link here, or you can even check out the link in the description box to see that video. In that video, we had, as I said earlier, had spoken about a very important topic, that is string immutability. In this particular video, we will further continue about speaking about string immutability. We will see what are the effects or what are the issues of string immutability and how can we resolve them further with various options that are available with Java. So, in my last class, we had seen a similar example where we had created an alphabets variable which was initially set to blank. Then we created this for loop which was looping from A to Z, and it was concatenating the various characters to the alphabet series. When we printed this set of alphabets, we could see that the whole A to Z was concatenated to alphabets. Okay, but there is one issue with this whole little for loop that you see here. Even though this is only 4 lines of code that you see here, it has a really big issue. What exactly is this issue? That with every declaration that you see here, initially with this first line, that is line number 6, wherein we are setting it to blank, this is going to create one memory location. Further, if you come to line number 9, you will see that with every concatenation that is happening here, it is occupying one particular memory location. Although this particular memory location is immediately marked for garbage collection when it is again being set to a different value. But yes, we are, for this simple 4 lines of code, we are occupying some 27 different memory locations. Now again, if you see further here that we had created this variable immutable and we were concatenating this immutable variable to alphabets. Now, if you print this particular alphabets variable, what do you think will it print? You will say that it will print the whole A to Z along with the whole string, that is strings are immutable. But if you go ahead and check this out, you will see that it is not printing the strings are immutable along with it. Why? Because strings are immutable on their own. They cannot, change their original state. If you say concat here, or if you try to attach some variables directly to it. Here it was working because we were saying plus equals to. We were changing the reference of alphabet variable every time to a new memory location which was holding the new character, which is not the case otherwise. So this is one of the primary issues, that because strings are immutable, they will every time occupy a new memory location if you want to change their original value. Okay. So originally the actual alphabet or the actual variable is not changing its value. What is changing is that the variable alphabet is now referring to a new memory location which holds the new value, and the original location which was there is being marked for garbage collection. Now, string provides us with a solution for this. What exactly is the solution for this is basically a class called as a StringBuilder class. Again, StringBuilder class is a part of a package called as java.lang, because of which you don't need to separately import the StringBuilder class. Okay. Now, StringBuilder class, for creating the object of a StringBuilder class, you need to say StringBuilder sb is equals to new StringBuilder, and you can say a blank bracket. This is one way of declaring it. There are other ways also of declaring it, wherein if you can see here, you can pass a character sequence to it, that is, you can pass some string inside it. You can pass an initial capacity. This is going to be an initial size of my string builder, or you can even pass a string variable inside it. So there are different ways in which you can do it. Okay. So let's try to replicate what we did here. Okay, so if I want to have a similar functionality, what I'll have to say here is that I'll say for, again I'll say char c is equals to a semicolon c less than equal to z and c plus plus, and then we will say sb dot append. Again, understand sb is not going to allow you to say plus equals to, because this is a class and classes will not allow you to say plus equals to, except the string class, because it's a special class. It will allow you to say plus equals to, but a string builder class will not allow you to say that. So you will have to say append, and it will append c here. Okay, so if you try to print the string builder now, string builder, you can see that it will concatenate. You can say it will give you a similar result. So if I try to run this particular code, you can see both the lines are giving me similar result. Line number 14 and line number 20. Now again, replicating the previous part, if I say sb dot append, again understand there is no concat method available in string builder. We have to use append. So you have to say append. Again, you can see there are a lot of overloaded methods which are available with the append. So practically you can append anything in a string builder object. You can see you can append boolean values, character array, character sequence, double, float, int. So as I said earlier, practically any type of value you can append to a string builder object. So I can say string builder dot append, and I can say immutable. And now if I print this particular string builder object, you can see that it will concatenate the value. So let's see if it is actually behaving like this. So I'll say if I print sb now, and if I try to run this, you can see it has concatenated strings are immutable to it. So as I said earlier, to resolve this particular issue, wherein because strings were immutable, they were every time occupying a new memory location. To avoid that, you can use a string builder class. Now there is one more version of string builder which was available earlier, okay, and that version is of a string buffer class. Okay, but string buffer class are thread safe. Okay, so they are comparatively going to be slower than the string builder class. Okay, they are very similar to that. Even the declaration, if you see that I am doing right now, is very similar to that of string builder. But you should always prefer string builder over string buffer, because string builder is going to be faster than string buffer, because string buffer is threads. Okay, so you should always prefer string builder over string buffer is what I'll say here. Okay, let's go ahead further and understand what are some of the important methods which are available with the string builder class. So these are some of the important methods which are available with the string builder class. These particular methods you will find are quite similar to that of the string class which is there. So you can still leverage the benefits of the string class, plus you can even make sure that you are not wasting too much memory for whenever you are concatenating some data to any particular variable. So let's quickly start looking at each of these methods and how do they behave. So we will start of course with the append method, which you can see we've already done here, which appends a particular practically anything, as I said earlier, to the string buffer class. Insert is again a very interesting method, and it is similar to buffer, but if you see there is a little difference in string the append method of the string builder class and the insert. So if I say sb dot insert, you can see it asks for an offset. This is one difference between insert and append. Insert will insert it at a particular location. So again, insert method also can practically insert anything that you want, but you need to provide it an offset. So if I take an example, something of this sort, okay, and I try to insert, say, let's say at the 15th position, so I'll say 15, and I'll say some particular string here, let me say string builder. Okay, let me say something of this sort, and I try to run this. Let's see how it behaves. So you can see at 15th location it has inserted the word string builder. So if you quickly check this, as I said earlier also, the indexes will start with 0, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and at the 15th location you can see string builder string has got inserted. The next method that we have here is replace. So again, this is going to behave similarly the way it has behaved with the string class. If you haven't seen my earlier video, please go and check out wherein I have shown you the similar methods which are going to work for the string object also. So what are we doing here? Now we are doing replace. So you can say string replace. It needs a start, it needs an end, and what do you want to replace? So let's say the start position is, let's say 15, comma, let's say the end position is 25, and I'll say I want to replace it with the word string buffer. Okay, and let's try to run this. Let's quickly see how it behaves. So you can see this is got replaced. So from 15 to 25 it has got replaced, and post that you get the remaining part of the string. Okay, then the next that we have is the reverse. So if you simply say sb dot reverse, this is going to reverse the whole string. Okay, again this is going to get impacted on the sb object itself. So if you see here, this has got reversed completely. Now let's see what happens when you try to print SB. Now you will understand exactly the difference of how string builder behaves. Understand that when I'm saying SB.reverse, this is actually happening on the SB object. The whole data has got reversed. So when I also print only SB, you can see because the whole string builder object has got reversed, this has affected the whole string. So if I want to get it back to the original state, I will again have to say reverse here. Okay, one more time. And if I see now, this will come back to its original string that was there earlier. Okay. Further, the next method that we have is char@. So again, this is similar to what we had in string. So you can say sb.char@, and you can provide an index. Let's say I say index number 26. So if you try to print this, it will show you E. So somewhere here it is going to show you this particular, I think it is this one, because we had earlier replaced it at 25. So somewhere this or this character it is. So you can see that. Okay. The next that we have is delete. Okay. This is going to delete a set of characters for us from a start location to end location. So I'll say I want to delete whatever is there between 15 and 25, whatever is there. Okay. So this is there. If you can see, it has completely removed the values. Okay. Again, it has removed only up to 25, as you can see here. This string buff which was there has got removed. 10 characters have got removed. 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. So up to here you can see has got removed, because you can see you have this FER here. Okay. Going further, we have another method, that is delete character@. So we can say sb.delete char@, and we can provide a location. So now let's say if I provide 25 again, this will remove the character at the 25th location. So let's try to save this and try to run it and see how it behaves. So you can see it has further removed the character. You can see this is one less than the earlier one. So it removes the character from that particular location that you mentioned. Going further, we have length, substring and index of. So let's see how this behaves. Okay, so what I'll do is I'll say sysout. Okay, and I'll say sb dot length. Okay, if you print this, this is very similar to what we had seen for string class also. So print as the length. So it is 54 characters. One thing that you can do here is you can say dot. Here you can say sb dot substring. Okay, and we can say you can provide from which location do you want to start the substring. Again, the method you can see is very similar to that of string. It has two versions, one with a start index alone and the other one with a start and an end index. We will say from let's say 36th position I want to substring it till the end. Now if you run this, this is going to tell us 18. Now why is it telling us 18? Because this is a kind of chaining that we are doing. Okay, so what it is doing here, it is doing a substring. It gives me the string object, and then on that particular string object we are calling the length method. Okay, so this will give us the length of 18. Okay, so again understand the length which is getting called on what? It is getting called on the string and not on string builder object that we have here. Okay, because this is a kind of chaining that we are doing. Whatever this particular method returns, this particular method gets applied on the output of this method. This is this kind of implementation or this kind of concept is called as chaining of methods, wherein we call one particular method that the output of that particular method we use to call the other method. Okay, so that's basically the concept is called as chaining. Okay, just for your reference I'm writing it. Then what do we have next is we have substring length we've done, we have index of. So this is again very similar to what we had seen for string. So sb dot index of, as you can see, again you have index of, you also have last index of. Last index of is also similar to what we had seen for the string class itself. So we can say index of and we can provide a string here. Let's say I want to find the index of the word strings. So this might not be a whole word, it can also be single alphabet. So I'll say S, save, and I'll run this. It will tell me this is location 32. Now, as I said earlier, I can just say S. In that case, it will give me the first occurrence of S. Again, here in this case, although the first occurrence of S is this only. So let's try to run this. Let's see what it returns. So it is giving us 38. Now why is it giving us 38? Because we've written small s here. Okay, so it is giving me the first location of small s. Okay, so that is why it is not saying 32 but 38. See, if you rather than saying small s, if you say capital S, this will give us a different index. So you can see this is giving us 32, which is this particular s. Okay, so similarly you also have last index of. So if I say sysout and I say sb dot last index of, and let me say m here, m, and let me say m here also. Okay, so you will see both the values will be different because index of will give me this particular location, last index of will give me this particular location, as we have also discussed this in the previous video. Again, if you've not seen the previous video, please go and check so that you'll be able to understand the difference between how a string behaves and how a string builder behaves. How are they similar to each other? How are they different to each other? As you can see, the indexes are different. This one is giving us 12, the other one is giving us 46. So this gives us the first occurrence, this gives us the last occurrence. Okay, so that is it. These are some of the important functions of the string builder class. If in case you have any queries regarding the string class or the string buffer class, please mention them below in the comment section. Also, please click the like button if you liked my content that I've shown you here. Click on the subscribe button so that you are never missing on an interesting video. Also, share my videos with your family, friends, colleagues, to whoever it is relevant to, so that even they can benefit from these videos. Also, check out other videos in this series that talk about some really important concepts of Java. I will mention the link below in the description box so that you can check out all those videos and even go through those videos to understand some other concepts of Java. So that is it for this video. Thank you. Bye bye. Have a nice week ahead.